Okay, this is lesson 8.2 and 3, and in this lesson we're going to look at using something called the cosine law. And like when we explored the sine law, the cosine law is not the same as the cosine ratio from SOHCAHTOA. The cosine law is actually based on Pythagorean theorem, but there's an adjustment included to scale it for non-right angle triangles. So we can use cosine law in non-right angle triangles or acute triangles. And what we're doing is we're either looking for an unknown side if you have the other two sides and their contained angle, which is important to note. It can't just be any angle, it has to be the contained angle. I'm going to show you what that looks like in a second. And you can find an angle if you know all three sides. So first, the contained angle. Well, a contained angle would look like this. If we knew side A and B, the contained angle would be C, the angle that touches both A and B. Side A and B make an angle, only one, and it's this angle C, which is the contained angle. If you have all three sides, it would just be side A, side B, side C. You could write a cosine law for any of the three angles. Now, I'm going to show you both versions. The first version is written to find side C, our contained angle situation up here. Side C is, well, side C squared is equal to A squared plus B squared, and that's just cosine law. Sorry, that's just Pythagorean theorem. The extra part on the end is the part that scales it, so if it's not a 90-degree angle, we can work through it. And that part is minus 2AB cos C. Sine law and cosine law, cosine law is based off of patterning. And if we look, when you're solving for side C, we need to use angle C. We need to have angle C. And the other two sides are here in the equation. A, B, A, B. If we're writing a cosine law for an angle, like angle C, notice we have angle C right here, and we have side C right here. And it follows through with A, B, A, B. Where's this second equation come from? Well, it just comes from rearranging the first equation. If you take a look at this equation and you wanted to rearrange it to isolate for cos C, how would we do that? Well, we'd move A squared to the other side and it'd become minus A squared. We'd move B squared to the other side and it'd become minus B squared. And we'd divide both sides by negative 2AB so that we could get cos C by itself. So this equation really just comes from rearranging this equation. All right, we're going to work through 4 examples, and I'm going to show you 2 examples where we're using cosine law to solve for a side, and then on the second part of the lesson, we'll do cosine law to find an angle. So let's try a side, and when we do a side, we need a contained angle. So let's go down here and make sure we have a contained angle. Find the length of the indicated side of each triangle to the nearest 1 decimal place. So we're looking for side B, and the question is, do we have the contained angle B? We do, 42 degrees, and we have the two sides that contain it, 36 and 52. So here we have a contained angle B around side C and side A. C and A, and we remember angle and opposite side are the same letter, angle and opposite side are the same letter, and we're looking for the opposite side from our contained angle B. So this is a perfect cosine law question. So now we have to try to write a cosine law for B, and we can do so by following the same pattern up here. If we want to write a cosine law for B, we start by writing B squared equals, and then we use the other two sides. The other two sides are A and C. So we're going to follow this pattern, but instead of using AB, we use AC. So we've got A squared plus C squared minus 2AC times cosine. And remember, the side we're looking for, C, needs to match the angle C. In this question, we're looking for side B, so our angle needs to be angle B. And now we've just written a cosine law for side B. All right, how do we use it? Well, we use it by filling in what we know. We don't know B squared, but we do know A is 52. So we got 52 squared plus c squared is 36 squared minus 2 times 52 times 36 times cosine 42 degrees. Now, I recommend, if we're doing this question, not to break this up. I would just type this entire expression into my calculator and get an answer. What happens sometimes if you break this up is if you square this and square that and do this multiplication, sometimes you end up subtracting here before multiplying. We need to make sure we follow BEDMAS. So I would take whatever calculator you're going to use, and I would try to make sure that I can type this entire expression on the right-hand side in and come up with the right answer. So the answer we're aiming for here is 1217.7. So let's see if we can come up with that. 52 squared plus 36 squared minus 2 times 52 times 36 cosine 42. And we've got it. 1217.665773. We're going to round it just to 0.7. So we've got 1217.7. Now, that's not what b is. Notice these numbers are significantly smaller than that number. This is what b squared equals. Just like when we're doing a Pythagorean theorem question, we do the squaring and then we have to square root at the end to solve for b, and that's our last step. We have to square root to solve for b. So I've still got my answer in my calculator here. I'm just going to hit the square root button and then my answer button. And I come up with 34.89. It wants one decimal place, so we got 34.9. And we're working in feet, so 34.9 feet. And we rounded, so approximate. And there is the cosine law. Let's try one more, solving for sides, and we're going to do it by first drawing the triangle. So we've got acute triangle MNO. We've got side M, side O, and angle N. So I'm just going to draw my standard isosceles triangle here. Whoa, nice little wobble. Oh well. M, N, O. So remember the side M is across from angle M. So we've got 4.8 here. O is across from angle O, so we got 5.9. I'm going to write O, I'll write M, and angle N is 63. And look, we've got our contained angle, contained between two sides we know, and we're looking for the last side, N. So now we need to write a cosine law for the letters M, N, and O, solving for side N. So we're going to start by writing N squared. And then if we follow the patterning, since we're doing N squared, this is going to end, this one was B squared, it ended with cos B, ours is going to end with cos N. The other letters that are going to go in here are M's and O's. So we've got M squared plus O squared minus 2 MO cos N. So remember the patterning. N is the side we're looking for, so N is the angle we're using. The other two sides are M and O. We've got M's and O's. So M squared and an O squared, and then minus 2MO. And you'll be given this version of the cosine law on a test, but we need to be able to use the patterning to write a cosine law for any letter in any three-letter triangle. Now we can fill in what we know. We don't know N squared. M is 4.8, so we got 4.8 squared plus 5.9 squared minus 2 times 4.8 times 5.9 cos 63. And now our strategy is just to type in the entire right side into our calculator. So let's see what we're doing here. 4.8 squared plus 5.9 squared minus 2, 4.8, 5.9, cos 63. And we've got 32.136, we'll call it, so 32.136. Now we can break this up if you want to show more work in between, but we need to be able to get this number. So try breaking it up if you'd like. I prefer just typing it in. Whatever gets you this number most consistently. And what I found is just typing the whole thing in gets me this number most consistently correct. So now remember, last step is to get rid of the squared by square rooting. I've still got my answer in my calculator. Square root answer, we get 5.66. We want one decimal place because the question gives us one decimal place. So we'll call it 5.7. And we're working in centimeters. And we're approximate. So there we go. There's two examples of cosine law to find sides. Now let's try finding angles. All right, find the indicated angle in each triangle to the nearest degree. So we've got triangle ABC, and we want to find angle A. Angle A. So we want to model this like our cosine law for an angle. Cos C, and we start with C squared. Since we're looking for A, we're going to start with A and A squared. And the other two letters in our triangle were B's and C's, so we're going to have B, C, B, C to follow the patterning. So our cosine law is going to look like this. Cos A equals A squared. Now the other two sides are B and C, so minus B squared minus C squared divided by negative 2. And then the other two sides were BC. BC. And there we have our cosine law. Let's label the sides. Across from B is B, so B is 5. Across from A is 6, so A is 6. And across from C is 4, so C is 4. So here we go. 6 squared minus 5 squared minus 4 squared over negative 2, 5, 4. Now, there's a couple ways to do this. The first way to do it would be to type this entire thing into our calculator and get a decimal. Alternatively, we can simplify the top and the bottom and keep it as a fraction. And that's actually the way I prefer to do it. So that's the way I'm going to suggest you do it. We've got cos A. Do the entire top in your calculator. 6 squared minus 5 squared minus 4 squared is negative 5. So we got negative 5 over, and the bottom is negative 2, 5, 4, negative 40. So we got negative 5 over negative 40, and we can get a decimal out of that if we want. If we type this whole thing into our calculator, it would have given us a decimal. 0.125, or a simplified decimal. It might have been 1 over 8, but what we did was simplify the top first, got negative 5, bottom second, got negative 40, and now we have negative 5 over negative 40. We could simplify those signs and make it positive if we wanted to, but to do the question, I'm just going to show you the last step. When we're solving for an angle, remember we have to use cos inverse. So we're going to do cos inverse of whatever that fraction was that we got. Now the negative signs are unnecessary. We can just do 5 over 40. But I'll keep the negative signs in there for consistency. So cos inverse negative 5 over negative 40. And we end up with 82.8, we want nearest degree, so we'll call it 83. And there we go. The other way we could do this, up to you which way you want. When we get to this step, 6 squared minus 5 squared minus 4 squared over -2, 5, 4. You could get the decimal, or you could go right to cosine inverse and try to type this whole thing in your calculator. And again, it's up to you to figure out how you can get the right answer most consistently, and that's why we practice. So when you try a couple of these for practice, see if you can type the whole thing in this way and come up with the right answer. If you can, you might like to do it this way because it saves you one step. So let's give it a shot. Instead of figuring out what this is, -5 over -40, just type that whole thing in. So here we go. Second, cosine inverse. I'm going to use my fraction button. If you're not going to use your fraction button, what you should do is put the whole top in brackets and then divide. But I have a fraction button, so 6 squared minus 5 squared minus 4 squared over -2, 5, and 4. And I get the exact same thing, 83 degrees. So it's up to you how you want to type it in, but we need to be able to come up with 83 degrees. So what I'm going to do is I'm going to leave you with B as your practice question. Give it a shot. Try to write a cosine law using the letters Q, R, and S, solving for angle Q. So it should start with cos Q. And try this one on your own. The answer is on the course website, but what you're aiming for is 40 degrees. So see if you can come up with 40 degrees. Thanks for watching lesson 8.2/3, and I'll see you for our last lesson, 8.4.